All right, pre-calculus 30, 6.3. This is question number 51 in proving identities. And so we're going to get going with number 51. So in this question right here, the more complicated side looks slightly more like the left side. Okay. And I noticed a couple things. I do notice that 1 minus cos squared is sine squared on the bottom. Now here's the thing though. I don't see sine squared on the bottom over here. So I'm not sure if that's a good idea to move that right now. Okay. I'm not sure if that's a good idea to substitute that just yet. Notice that 1 plus cos theta is actually a factor of this. It's a difference of squares, isn't it? So let's just hold on to that. Let's not focus on this bottom part first. Instead, let's focus on the top part. Now, the top part is this is one of these questions where you want to notice that this is a quadratic form. 3 terms. You've got something squared minus the something variable plus a constant. So that is in this form. It is in 4x squared minus 5x plus 1 form. You see that? You see how that mirrors this right here? Now, if we were to factor this, right, this would be 4x times x, 1 and 1. I have to add to 5, so to negative 5, so that's going to be a negative 4x minus another 1. And negative 1 times negative 1 gives us plus 1. So if you're having trouble factoring this by sight, that's okay. You can use decomposition. We learned in Foundations Math and Pre-Cal 10. You can look up that video if you need to practice your quadratic factoring. But what that means is that I'm going to be able to write this this numerator over here as 4 times cos theta minus 1 times cos theta, whoops, minus 1. Okay, so see, this right here was just sort of my cheat sheet, right? That's my the simple way of factoring, just without all the cos and stuff. Just substitute an x. It looks a little more familiar. But now I want to substitute the cos back in to the x here. Okay. All right. So what is that all about? Well, I'm looking at 1 minus cos squared now, and noticing I have something that's pretty similar to a factor of 1 minus cos. So let's just factor this. That's going to be 1 minus cos theta times 1 plus cos theta, right? The difference of squares. Okay. Switch colors. Notice this now, okay? So 1 minus cos theta and cos theta minus 1. Those are not the same, right? They're very, very close. If it was addition, if this was plus and this was plus, they would be exactly the same. But it's not. And so what we have to realize is that when we have, like, here's just a totally different example. 5 minus 3 and 3 minus 5. This is positive 2, this is negative 2. Okay, so the numbers are the same. The values may be the same, but one is negative of the other. Okay, so what that means is that if we either multiply or factor out, that's the best way to think about this, factor out a negative from one of these. So I put a negative 1 as a factor up there, factor out a negative. This becomes negative, that becomes plus. And now they're exactly the same, you see? Plus 1 minus cos, plus 1 minus cos. So the shortcut, if you see this where it's a subtraction, but the terms are reversed, you can divide them out as long as you put a negative 1 as a factor on either the top or the bottom, doesn't matter. Okay. All right, so now that we got through that, we've simplified this a bit. And what happens when I multiply this negative in here? Well, look over here. Look at this. We're pretty close here, aren't we? It's actually negative 4 cos theta plus 1 on top, and 1 plus cos theta. Well, if you just rearrange those, that is exactly the same as what we have over here, isn't it? There we go. See? 1 plus cos theta. So there you go. The left side now equals the right side. You're good to go. And just, in case you're curious, if you did start with the right side, you probably could, and I'm not going to do it in this video, but you probably could multiply 1 minus cos theta, top and bottom, to get this difference of squares. And then actually that's going to be pretty close, right, to what we have up here anyway. So it's going to be 1 minus cos minus 4 cos. plus 4 cos squared theta. Yeah. Actually, that's going to be really easy too. So if you did it this way, it would be a pretty simple, straightforward proof as well. All right, I just wrote it out there for you. It's actually a really simple proof as well when you just multiply by the conjugate there, top and bottom. You just rearrange the terms. It's actually maybe a little easier than the one I did even. Okay, there you go.